Now I'm going to illustrate a demo I call transverse waves. When we learn about waves, we learn that there are transverse waves and longitudinal waves. And I have another video that I illustrate traveling waves, and I show you the difference between longitudinal and transverse waves and how they travel. So you can watch that video. In this one, I'm using a particular instrument to illustrate the transverse wave. In nature, transverse waves, examples of transverse waves would be waves in strings, and another example, very famous, is called electromagnetic spectrum. The waves of the electromagnetic spectrum, such as visible light, radio waves, X-rays, and all of that, they're also transverse waves. So the idea of transverse wave is that the wave energy will be propagating this way from left to right or right to left, but the wave elements themselves will only be propagating up and down, perpendicular to the wave. So the elements of the wave are traveling, are moving up and down. So when students first learn about this, it's kind of weird that the particles themselves, the elements themselves will travel this way, up and down, but they will carry energy from right to left or left to right. So how will the energy carry in a direction that's perpendicular to the actual movement of the wave? So that is the kind of the surprising thing about electromagnetic waves and about waves in strings. So this demonstration illustrates that. Essentially, you have a bunch of rods that are connected together tightly, right? And the connection, how strongly they are connected will determine the tension. So when I move one up and down, that will exert a tension on the one next to it, and the next one will start moving up and down a little bit time later. So for example, you see on this one, on this side, I'm moving this up and down, and you see how they're all moving with it because they're connected. So I'm just moving it up and down, and you will see a wave will form where the wave will travel this way. With this demonstration, it's a bit hard because it tends to lean over, so I'm going to hold it like this. You see here how the wave I'm creating up and down, and all the elements of the wave are just moving up and down, but the wave energy is traveling left to right and then bouncing back and traveling right to left. You see there? Like that. And that's essentially what a transverse wave is. Really interesting. To me, it's a really interesting phenomenon how the wave can travel, the wave elements can travel in a direction completely perpendicular to the direction of the energy of the wave. Like that. You see? The wavelength of the wave will decrease if I increase the frequency. So I can show you here how these are connected. These rods are like this, and they're connected in the middle using these aluminum connections. So the strength of that connection will determine, when I move one up and down, how fast the other one will propagate up and down. This is a little bit similar to how a rumor might spread. There might be a bunch of people, right? And then a rumor starts here, up and down. This person doesn't necessarily have to travel all the way to the other side to get the rumor across, right? He can tell this person something, and that person can tell that other person something, and then the rumor can spread this way, perpendicular to the direction of the actual people saying it. The people are not actually moving right to left. And they can transmit that information to the other side, and by the time it gets to the other side, of course, the rumor is all jumbled up and, you know, changed, and the message has been changed. But you can kind of get the idea is that you can get a message across from one end of a room to the other, right, without actual people moving from right to left, by just getting a message from one to the other person, from the other person to the other person, and so on, right, in a direction perpendicular to the direction of the flow of the energy. Okay, so now with this demonstration, you can see a little simple demo of how a transverse waves work. And even though the elements themselves are not moving from right to left or left to right, the energy of the wave is traveling from right to left. Okay, thank you very much.